Hi everybody, we will continue exercise number 6. So now we need to solve part 8. Study the relative position between curve C and the tangent T found in part 7, which that have an equation y equals to x plus 2. So first of all we need to evaluate the expression of f of x minus the equation of the tangent to x plus 2. So taking a common denominator x squared, you will get the numerator expression is now x squared minus 1 minus x squared into 2x plus 2. Now expanding the numerator expression and reducing this expression, you will get a simplified expression minus 2x cubed minus x squared minus 1 over x squared. Now we need to find the roots of the polynomial in the numerator, or we need to find the values of x where f of x minus yt is equals to 0. So taking minus 2x cubed minus x squared minus 1 equals to 0, one may use here the calculator, mode 5 4, then plug the numbers minus 2, minus 1, 0, and minus 1. Because this is a polynomial of third degree, you will get 3 roots, one real root which is minus 1 and 2 complex roots which are rejected. Then drawing the sign table of f of x minus yt, first you should plug the domain of definition, and then you should plug the value of x where f of x minus y of t is equals to 0, which is minus 1, and here between minus infinity and minus 1, the sign of f of x minus y is positive y. Just for example, take any number between minus infinity and minus 1, let's say minus 2, put minus 2 in the expression of f of x minus yt, and then you will get a positive number. Similarly, take minus half, between minus 1 and 0 you will get a negative number, and take 1, let's say between 0 and plus infinity you will get a negative number. Then c is above t between minus infinity and minus 1, c is below t between minus 1 and 0, and also below t between 0 and plus infinity. So before moving to part 9, here let me say a remark that when x is minus 1, the curve C intersects the tangent T at a point of abscissa minus 1. And how to get the ordinate of this point? Just plug minus 1 in the expression of f of x, or in the expression of the equation of the tangent, and you will get the ordinate of this point of tangent C, or the intersection point. So the intersection point here between the curve C and the tangent T has an abscissa minus 1, and if we plug minus 1 in the expression of f of x or in the expression of the equation of the tangent, you will get the same answer, which is 0. So the point minus 1, 0 is the intersection point between curve C and tangent T. Question 9 is to find the intersection point between curve C and x prime of x. First of all, let me remark that curve C has an equation y equal f of x, and x prime of x has an equation y equal to 0. Then putting y equal y, let's say, then you need to solve the equation f of x equals to 0. So in order to solve f of x equals to 0, we replace f of x by its expression, and then solving this expression you will get x squared equals 1, which is x equals plus or minus 1. The ordinates of the points, intersection point between curve C and x prime of x should be 0, the ordinate. Why? Because the equation of x prime of x is y equals to 0. So the ordinate of the points of intersection should be 0. Then the coordinates of the intersection point, we have two intersection points, 1 0 and minus 1 0.